And good evening, good afternoon, good morning, everybody. Welcome back into the Dragon's Den. Hope everybody's having a great week so far. Hey, Zombie, thank you for the lurk. Uh, Rob C. Quantum Assembler, how's it going? Good evening. Hey, Mr. Wizzix. The Shrimp Father, hope you're doing well. Tech Jeeper, how's it going? Timor, hey, hey, hey. Book Allen, how's it going? I hope everyone's doing well. Hey, Eagle the Dragon, how are you doing, bud? Hope you're doing good. Hope you're doing good. So hopefully, people are picking up on some changes. Um, you may see that there's something over here that hasn't been over here in a little while, and that'll be an indicator of something. Um, but basically, the office setup has changed around a little bit. And what I mean by that is black box, black stack, and the E drive is back over here. The RatRig is now turned back around and up against the wall like it's normally. We've got both tool heads on here. We've got a RatPack in here as well, which is the air filtration system for that. And we're close to being done. I think tonight my intent is just going to get a print going over here, and it's going to be a functional and interesting, well, maybe interesting to me print, because there's an issue that we're having to chase down over here, and I'll get into that a little bit. But I hope everybody's doing well this evening, and everybody's having a good day. It's been an interesting week for me so far. We're my direct boss and a couple of other people are leaving tomorrow, I think, for a conference through the end of the week. So hopefully, I will say, hopefully it'll be a quieter back half of the week. We'll see. But tomorrow, we've been working the last couple of days to get a briefing ready for our VP. It'll be the first time we're doing metrics readout for him this next or tomorrow. So a little bit of everybody puckering up. We'll do the brief. Everything will be fine. Everybody will realize it's a big nothing burger, and then we can start living our lives again. But yeah, fun. How's it going, Tech Team? So yeah, so here's some of the things that's been going on. With the that's not what I want us over on the other. So one of the things that we need to do is run a de-offset, right? So let me kind of bring some things up here. Go to the browser window. You'll be able to see over here. I could move the camera over there, but I think it'll be fine over here for what it is. And what we're going to do is turn on the small application, right thing. There we go. And basically, a couple of things here. You'll see that we've got fan, which is the same thing as part fan 1, or part fan T0, part fan T1, and then the filters. This would be the RatPack air filtration filter. And it's like a big 120 size fan. It's very quiet. But we're going to do a home. Oh, and I realize that is right exactly where we're going to go. Right exactly where you're going to not see anything on the screen. So we did a home, we'll do a Z-tilt. And actually, I am going to bring this back around so it can get closer because I want to show you a couple of things when we go to do this. Am I or am I not? Thinking about my wires right now, so bear with me. Bear with me. Ah, the wires, they are everywhere. Okay, so we are set up. We've done our homing. Okay. Now we're going to go into the VAOC menu over here on the left and, well, dial that back down a bit. Okay, and we're going to say start calibration. What we're going to be working on here is aligning the nozzles between the two tool heads. Now, mind you, yeah, so this is a 0.05 nozzle and a macro view. So all we're doing is kind of trying to line that bullseye right up in there. And I'll be doing some very minute changes. Now, you'll notice that you might have caught that I said this is a 0.5 nozzle. So I had the 0.6 nozzles and I was still getting some issues back and forth. And believe it or not, even though these are both Rapido nozzles that came out of Rapido tool heads, they are completely different finishes. So I decided, since I had them, that I would switch over to, what is this thing doing? I have no idea what that was doing. Just okay. That I would switch over to some gamma 0.5 nozzles. So that's what I'm doing, and I'm just making sure that these nozzles are lined up when I switch back and forth between tool heads. Hey, Sigarecki, how's it going? Hey, Zombie Hedgehog, how's it going? Why are you not? Bear with me here. I know what this is. This is, I think, my Wi-Fi being stupid again. And once you can go back and forth and they're lining up pretty darn close, then we'll go ahead and do the next piece. And this is also the fact that I put the back plate on the, I have a back plate on the electronics enclosure, which means the electronics and the Raspberry Pi are fully enclosed in a steel shroud. Hey, Da Vinci, how's it going? Eating dinner, then heading out for D&D. Awesome. Where are you playing D&D at, Sigareki? I've been doing that on Fridays, Evil Diesel has me going out to the local game store here, Raven Forge Games, and we've been playing D&D on Friday nights. And past Sunday, I went out and started painting some miniatures. So I assembled a small set of 3 Ultramarines, and then brush primed them. Go over to a friend's house every Tuesday for, there you go. Nice. Yep, there you go. Okay, so we're pretty close here. Now the next thing we're going to do is say calibrate Z offset. And what it's going to do now is it's going to start switching over, and it's going to touch the tip 5 or 6 times off of what in essence is the sex bolt, which is a Chicago bolt in the spring over the top of an Omron high quality micro switch. Yeah, pretty cool. Okay. So if I go back over to mainsail, I think it auto calculated, but it might not. I might have to go back over and actually hit the square and kill the thing. But yeah, there you go. So it says we have a high toolhead Z offset of 0.09125. Toolhead Z offset could be better. Use a minimum of 0.3 layer height. What they want us to have is a 0.05, I think, or less. And I have continued to try and do this, and I'm still having issues trying to do a copy where whatever I'm doing on the right hand side is too far away from the board. So long story short, saying I can print with toolhead 0, the left toolhead. I have not been able to get a successful print with the right toolhead, toolhead 1. And I have gone through and done everything from completely taking the nozzle and the heat break extension out, because this is the ultra high flow, so it's got the adapter to make it even longer. And reseating those, hot tightening both components separately. I just swapped out these gamma nozzles, so I know that they're the exact same nozzles, same material, and they're going to heat up at the same rate and have the same thermal expansion. There is physically something different in the build of the Rapido hot ends, and I do not want to tear down the top half and try and rebuild those. So instead, my solution was to go out and go on Amazon, and I now have some 304 stainless steel shim material that goes down to 0.01 millimeters. So I'm going to shoot for a 0.1 millimeter shim material, and then I'm going to drill it. So what I'm looking at doing is I'm going to, yay. And like I said, this is what's happening with the Wi-Fi right now, as it keeps doing this good thing. And let me get over here into the VAOC again. I need to cancel out the process. Let me. So my plan is I'm going to actually print a Rapido 2 mount of some sort, right? Oh, why? Why do you do this? Okay. As it continues to play its game of pain and stupidity, I will move this back over. Come on. So in order to do this, I swapped the USB cable for like a, I don't know, I think it's like 5 meter long. So it's like a 15-foot USB cable. This dragon just went on a Dunkin' run for me as well. So we got coffee. But now what we're going to do is fight with that and figure out why it still won't come up on the network again so we can get a print going. You've never heard of a RatRig printer that makes them special, and what experience level is the user experience? Hey, Luca. So the RatRig is a company out of, I believe it's Portugal. They started off, believe it or not, making camera sliders, and there was a lot of people that kept asking about other products. So they've now got CNC, like long bed CNC machines for cutting wood and other materials. They've got a desktop milling machine that I've got a beta unit of. They have a workbenches. So the bench that you see this printer sitting on is actually 4040 aluminum extrusion, and it's a kit that you can get from RatRig. All you need to do is provide your shelf material, and so that's what I did here. The user experience is actually pretty good. The Rat OS does take a little bit to get used to, but it's a lot of quality of life wrappers around standard clipper. They did nothing to change the underlying clipper like you've seen with Anycubic, Creality, Elegoo, or any of them. When you go into mainsail, it is a true clipper mainsail experience. They haven't nerfed it in any way. What they've done is they've extended the interface with a separate web browser interface that adds other capabilities. The printer is rock solid. This printer here is a true 300 by 300 by 300 build volume, and it prints beautifully. It kind of looks like a Trident, but these rails are MG15, I think H rails. They are beefy. You see these types of rails and these size rails on desktop mills. We've got standard MGN12s on the Y and the X axis. I had this set up as the hybrid, which was Core XY motors from the bottom, and then it had two motors at the top that just added additional torque in the Y direction. And best input shaper graphs I've ever had out of a printer. It's very robust, made from 3030 extrusions and sheet metal. The enclosure, so the back panel is ACM, and then the rest of the panels on the sides, top, and front are 6mm polycarbonate. The deck, this is a steel deck, so this is steel plate for the deck panels in two sections. Very robust, very heavy, and that's why when we were working on this, thank God it was on a cart, got rolled out of the way, And I moved the camera setup over there and we were basically working right here, you know, at the end of the bench, because I'm not moving this by myself. At most, I was able to rotate the whole bench around. So very robust. And yes, because it's IDEX, and this is with any IDEX printer, the nozzles have to be at the same height. And some, I was reading about one of them where basically you get close to the bed, and there's a little bit of a height adjustment to the mount of the heads, and you basically loosen the screws, let the heads drop until they're flush, sitting on the bed, and then you screw both side screws in to lock the height of the axes or the tool heads in place. That works beautifully. In this case, there is a CNC cut aluminum plate that goes across the carriage on each head. So what we've got is physical tolerance difference in the tool heads as they were assembled at the factory. And even if I took them completely apart and rebuilt them by myself, the chances of those two tool heads being 100% the same height are slim and none. So that's where I'm saying they're built, neither tool head's leaking. At this point, the best thing I can do is add some shim stock between the top of the tool head and that mounting plate to make up that difference. That is the safest bet to get these two tool heads 100%, well, not 100%, but a lot closer. I mean, we're 0.09 millimeters difference. Let that sink in. 0.09 millimeters difference. And it has effect on whether it's sticking or not and printing right. I've also noticed, and let me come back into mainsail. Let me switch over here. So I'm gonna, once again, this is part of that extended interface. You've got setup wizard, dashboard, motion, visual calibration, real-time analysis and stuff. This is all of that extended thing. And when I click on this to go back to mainsail, this is a standard mainsail interface. The only thing they've really done is something I've been starting to do is set up groups for the different macro settings. And this was normal for a multi-tool head system. They've added a link in here to their configurator, the real-time analysis, and the VAOC, which takes you into that separate website link, basically. That's all they've done. So they've extended the interface. They haven't changed or fundamentally taken away anything. I can come in here, go into the configurator and do stuff, where on like the K1C, the Anycubic, I can get to a fluid web interface. I cannot change the fluid web interface, right? In essence, they've nerfed it. Oh yeah. And I will say it's even more robust because, we've got our boron 300 size machines over here in our 2.4 and our Trident. The Trident's the closest analog, but the Trident over here in the corner is made out of 2020 extrusion. So it's not as heavy and it's not as robust. Like when you pick it up, you can feel it kind of give a little bit, right? It's not structure and sound. It's just you can feel the difference in the sturdiness, right? This is also a 300 by 300 build volume, but 270 in the height, so you lose a little bit of the height. This is a massive machine. This is not something I am picking up and moving by myself. My buddy Evil Diesel came over and helped me move this. He's also helped me move this up and down. This is a 300 by 300. What's the build height on Zombie if you're here? Can you remember? I can't remember the build height on the black box. It's like 250-ish or something like that. But this is the black box. This is a 5-head tool changer running Duet, and this is built with 40/40 extrusion. Beefy, robust. Beefy, robust. But as you're dealing with IDEX and tool changers, you need that strength. You need that rigidity. Otherwise, you get flexing, and you have issues with things flexing as it moves around. Yeah, I mean, so Luca, I would suggest a Bamboo series printer, A1. Um, the Ender High or Ender, I don't know what they're called. The Ender High combo that just came out is looking like a good one. Another good, low cost, entry level machine is the Adventurer 5M and the 5M Pro. Those are really solid Flash Forge Adventurer 5M, really solid Core XY builds. Everybody's coming out with their own little Core XY build now. Somebody just told me about I think it was Timor maybe in my Discord made mention about the Kangaroo. Just came out with one. I can't remember the name of it. But what I'm going to do right now is I was searching real fast for a Rapido 2 style mount, right? I'm not going to print the whole thing. All I really need is the bolt pattern. And what I did was I grabbed this one because it looked like the easiest to bring into a slicer. So I downloaded this. Let me go over to full display. So I downloaded this, brought it into the slicer, and I just cut a portion off. I don't need to print the whole thing. I just need to print a part of it, right? And once again, this is Parthenax. Why is this set up on the... Thought I created 05 nozzle, PLA, PLA. Not a big crosshatch fan. Everything's set to 0.5, which is the size of the nozzle. Speed. This thing sets the speed pretty darn, we'll say, aggressive. We'll run it. This will be a short print. I may wind up having to come and, we'll say, slow it down some. The other thing that I might want to do, really need this filled and make it solid. Because what I'm looking at doing is I need this to be able to sit down, draw the pattern, but I also want to drill down through this into the material because the shim material itself is so thin. If you don't have it supported on both sides, as soon as that drill hits it, it's flipping around and it's blowing out, tearing, ripping. I need to clamp this down and drill these 5 holes and then basically, I don't think it needs to be a circle per se. Rectangle's fine, but I just need to be able to trim it out so that I can slip it in on the top of the, the hot end. And of course, I'm not sure if I'll be able to get the hot end in and out without actually having to take off the front shroud. And if I take the front shroud off, I have to take the belt off to do it, which means retensioning all the belts. So I'm going to try and do this in such a way that I can just pull the hot end off, get everything lined up, maybe cut the round around it as close as can be, and then bring the hot end in, turn it, line everything up, put the screws in it, and get it back in there with that shim just to make it a tighter tolerance there. But yeah, so I'm gonna probably just print this. Yeah, we'll leave it that way and we'll print it this. We'll try and go with the speed because why not? Slice complete. It'll be 5 minutes. It'll probably take longer to heat up and go through its starting routine than it will to actually print it. And by the way, make sure you're selecting the right material. I had 3 fails yesterday, and as I was trying to figure out what those 3 fails were, it was because when I finally looked at it, it dawned on me I was printing PLA at ABS temperatures. PLA does not like being printed, or yeah, it does not like being printed on a 105 to 110 degree bed and 250 degree temperatures. I mean, it printed until it failed. 300, 300, 275. There you go. Thank you, bud. You've relegated your laptop to doing all of the slicing designing. Yeah, so I was trying not to put slicers on this rig in front of me. This is my streaming rig. It was actually my gaming rig, and the only thing on it was antivirus and game. Right, that was it. As slimmed down, no bloatware that I could get. And then I started streaming, and I don't game as much anymore because I'm streaming. So then it slowly picked up. Now I've got Prusa Slicer on, Norca Slicer, Cura, and Idea Maker, and Fusion, and everything. But I really like doing, so I slice on here or stream. Otherwise, I'm doing everything on my MacBook, which is a new M4 Pro, or Pro, M4 Max, or Max. It's basically the biggest M4 Max. So M4 Max, 64 gig of RAM, and I think it was a terabyte hard drive, right? So kind of went big. Now, here is a couple of prints that I did. This is the this is one of the RatRig prints, right? We got the rat on the front. That's the Y, the X, the Y, the X, and this is their punk type of thing because remember they're punky punk fill. Besides the little bit of stringing, you can see the kind of poor print quality on this spike, off, right in front of my shiny head. And that's as far as I can screw it in. The thread's printed beautifully. It's just, this once again is a 0.6 nozzle, and I would just have to really tune the profile for a 0.6. Now looking at the top there, if I can get it to focus on that, I guess I should, I don't know, stop fighting some things and go, hey, I've got a camera over here on the bench. So top layer wise, Top layers are good. It looks a little tiny bit over extruded. So I can work on my extrusion multiplier some, right? But it was really, this is an overhang right here, and you can see how sloppy and curled up that overhang was, right? So we switched over to the 0.5 nozzle. Once again, you'll see this failed. Printing PLA at ABS temps. Kind of doesn't like it, but look at the overhangs just going from a 0.6 to a 0.5 nozzle. Once again, our tolerances are still pretty tight, and I can't get this in without probably busting it. Our first layers are pretty good. Right? Overhangs and everything are doing good. It's just tolerance-wise, it's not fitting in and screwing in. So I decided, well, we're using Orca Slicer, so let's try an Orca Cube. So other than the fact that if I can get this Orca Cube to show, you will see a plethora of ringing, right? So I need to work on my input shaper stuff still. I have done input shaping, but I don't know why it's kicked in this bad all of a sudden. Got good first layer, or good top layer, and good tolerance. Screws in. Nice and flat. So the tolerance is a little bit easier to hit when you're dealing with a 0.5 nozzle, which is one of the other reasons. But let's just look at these two nozzles. These are both stock Rapido 2 nozzles, right? Look how much different the coloring is and everything in these. That's why I decided to go to two of the exact same nozzle types that I could verify were the same material, because this looks like different material here. So these will go back in a bag or a box somewhere, and we'll go with that. And another reason to at least use a 0.5 nozzle is that way if I ever do any high fill, like heavy glitter or anything with glass filled, carbon filled, or other fibrous additives, it should have an easier time coming out of a 0.5 than a 0.4. Less chance for clogging. Oh, and the correct build plate? Yeah, that helps too. And 60 for a graphics card. Yeah, so this is here we go. So I say we, me and Evil Diesel went out and discussed about this at Micro Center. This is a Gigabyte Aurora's Pro AC, the 550 chipset on the motherboard. It's got a Ryzen 9 5900X, which is a 12-core processor, which gives you 24 threads, 3.7 gigahertz. I like AMD, by the way. With 64 gig of RAM. I kept debating, do I do 64 or 128? Because I can max it out at 128. But I stayed at 64. Once again, I knew I was going to be doing Fusion over here. Where's my storage? Yeah. lots of storage. I've got, the reason I like this board is I'm running 3 M.2 um, uh, NVMe RAM or NVMe drives on the board, and then I also have spinning drives for long-term storage. Yeah, and I've got a NVIDIA GeForce RTX 3060. Now that would be the next thing that I would say maybe try and plus up is grab a new card, but the flipping cost of cards right now is crazy. Just insane. I think this is, what is this, like 1 gig? Can't be a, but bada bing, bada boom. This print is done. Now, the one thing I like about the RatRig is instead of being like a big purge line down one side or in front or doing something crazy, it does this purge blob in the front and then a wipe. So there's your little purge blob, and it'll do one on each side. So this is done right in the front left corner for the left tool head. And if you're doing the right tool head, it'll do the right tool head at the same time. And what this string is it does its purge blob as it rises up, and then it comes over and touches the bed to do a wipe to clear the nozzle before it starts printing. And once again, how well does it print? Well, there's the first layer. First layer looks a little bit, but I think we're overrunning this filament. I really need to slow the speed down for this. This is Cookie CAD. I believe it's Witch's Blue. That's the top. And it's got a shimmer fill to it, but it's definitely something that you have to be you have to dial in. It's a beautiful filament for doing prints like this. Kind of wasted on doing things like this. It's just what I happen to have out, dry and not too bad. Now, once again, what I need to do is go through this package because, well, I mean, it's Amy Love, like literally, Amy Love. Or maybe that's Amy 1 OBE. Don't know. But here's my package of shim material, and it's only stacked this nicely because I stacked it that nicely. But we've got all different kinds to essentially down to like aluminum foil. And there's 3 sheets of each size. So what I need to do is go through here and, like, this is obviously a much thicker material. I need to go through here and kind of find the different thicknesses. I think there's 8 different thicknesses in here. So I kind of need to lay them out and figure out what the thicknesses are. And you can start by just the feel of them. You'll at least be able to get close based on the feel. And then we can go from there. And what we can do is use our those things that you use to check thicknesses with, calipers. We'll use those to figure out the thicknesses that we have here. Something close. Something's not right. Or maybe there's more of that one. That looks about right. So I'm going to be looking for 0.1 thickness because I keep coming between like 0.1 and 0.9 to, I think the closest I got was 0.07. So I figure even if I stick it at 0.1, that will give me a, because I haven't gotten under a 0.07 deviation. So that will get me at the like 0.03 or high, you know, in that realm of possibility. And I can just keep adjusting from there. The other thing that you can do, you wouldn't want to do it on this build plate because it's textured, and you wouldn't want to take it off and just use the magnet because the magnet's not solid. It's not solid like, you know, one of these things. And these, as you can see, have a bow to them. So you don't want to use that. You would want to use something that's sturdy, like, I don't know, use a 1, 2, 3 block, especially if you've got the solid 1, 2, 3 blocks, right? Just set that down, bring your nozzles down on top of it. Whichever one touches first, there you go. Now you can use the material and slide it up underneath until you get one that's just snagging. Boom, there you go. That's the size you want to use. That would probably be the best way. Do a Z-tilt adjust, set them down in the middle, do your height adjustment there. Using these as basically feeler gauges to get your difference. I was looking, I've got a, yeah. So I had a square, but even this has a depression in the middle. So unless it's kind of out here on the ends, which it might be, let me do that. So here's something to realize. We were just in single mode, right? So that is, you've got 3 different modes. You've got IDEX single. That means you're printing a single item, either with the left tool head or a dual color using both tool heads for a single item. It goes right in the middle of the print bed, right? To do an IDEX copy, this is how easy it is. Click, whoops. So you click IDEX copy, actually do it this way. Just a little bit. I'll click IDEX copy. In fact, let me do a home first so that it pulls this closer. So it homes the Y, it homes the 2 X's to the side, it moves T0 in the middle with the beacon probe, and does the bed. Now you're prepped and ready to do a single object with one or dual color, dual material, both tool heads, right? So if I click on the button down here that says IDEX copy, it's now set up both of those tool heads, and each one's going to print on half of the width of the bed, left to right. Now, this is not going to be long enough to be able to get under both of these tool heads. So I would have to do something to move the tool heads in, and then I can drop them both down. What I would do at that point would be to take the plate off, and if I have a bare spring steel sheet, or if I had one that had a bare spring steel bottom, I would put that underneath, I'd flip that over so the bare spring steel is up, put this on top of it, line these up side to side and bring them down on here. First one that touches will be the left one because it's the one that's lower than the other one. I'll just get this touching, and then I would basically take my shim stock and use that as a feeler gauge to say which shim stock am I going to use. How's it going, Kenneth 3D Prints? And this is set up, I cannot. Hmm. So there's a thought. I have thoughts occasionally. So here's what I'm going to do. Um, Pop this off, just set it down there. I think I've got about 8 or 9 different beds over here. If I can find one that has just a spring steel on one side. Textured, 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 and textured. Closest thing I've got is a large PEO sheet. By the way, Ember Prototypes, Sanjay Mortimer. For prototypes, Digital Dragon. I could have sworn that one of these had a. There we go. So this is at least a PEI sheet. So that'll work. I'll slide this underneath here. Doesn't even have to be full back there, but I will. And what I'm going to do, because I know the left side is lower, I'm going to put this right underneath the thing. Yeah. I'm going to put it underneath there. I'm going to go to 1 millimeter and I'm going to start coming down. And close. That's pretty much there. We go back up. That actually centered on there front to back. So what I'm going to do, all right, there we are. We should be, we're flat. We're just now touching this side. So what I'm going to do, because I can't move just the one, and if I say IDEX single, everything starts moving again. But what I can do is M18, and that turns off the motors. So what I can do now is slide this one over so that it's over the other side. And now I can start taking my different shim stock sizes. Okay, that one, center. I'm going to take my different shim stock sizes and slip them underneath here and see which ones I can slip under and which ones I can't. One's thicker. These two are the thickest. This one's thicker. This one. Then feels thin. Maybe it's. like this one plus a whisper. Let me try. This one feels a little bit closer. I'm assuming that the tolerance of this stuff might be a little bit different. And I'm feeling a slight drag on the tips. This, I think this size, whatever this size is the winning size that I need to go with. And that means that the rest of this can be put away for now. How's it going, Pez Liz? Hope you're doing well. And I'm just kind of like feeling thicknesses here, if that makes sense. I could get in there and this is a little bit tighter. I could go through and do a, like I said, a caliper read on this stuff and see which ones that I'm picking. We'll do that. What the heck? How's it going, Pez? So those of you, Pez Liz is doing her birthday week. And so tomorrow, and I had this sitting on my phone, and I'm pretty sure that, yep, as soon as I went to it, it was going to change. But Pez Liz has imprinting color tomorrow. And then, let me see if I can find her announcement. There we go. Oh, that one. So imprinting color tomorrow with Polymaker at 7:30 p.m. Eastern. And then on Thursday, she is on the Twitch front page starting at 3 p.m. Eastern. So yes, let's go support Liz. And hey, Epic Man, how's it going? You heard from Peanut earlier? Good. Nomi's surgery went well and she's in ICU to rest and she should be off of sedation. Nice. Thank you for that update, Liz. I actually, that was something that was on my mind today, was her and her surgery. So thank you for providing that update to us all. I really do appreciate it. Okay, I'm gonna put that away, and I just recently put in a new battery in this, so we're just going to see what our material thickness is. And that was the 0.01 that I was looking for. I'm actually kind of squeezing it, but it's getting to there we go, 0.01 or 0.1. So this was the exact one that I was thinking I was going to need to make up the distance. So that's great. Definitely so happy that she's okay. I didn't think you were talking to me, but I'm part of the Lukes of the world. You are? Hey, Luca. Part of the Lukes of the world. There you go. Yeah, it's funny getting into the 3D printing community. I'm used to being one of the only Lukes around. I felt like that name had just kind of fallen off the face of the earth. And then in the 3D printing community, there's Luke at Big Tree Tech. Luke at Big Tree Tech. Luke Jewell over with Tugboat 3D. Luke's Lab. Me. Now you. There's Luke the Duke. I mean, there's, oops, I did it. I did come on. Gonna darn it, darn it, darn it, darn it. Oh, I want to do work. There we go. Boom. That's what I need. I'll stay there. Damn it. Well, okay. I keep forgetting I've got a tiny 2 now on the bench, so I have to be careful of hand gestures. Or can I shut off gestures this one? Have to. Oh, beauty mode. Make my face not push so bad. Page. Oh, I'll play with this later. Sorry, distracted. But yeah, there's quite a few. Spanish teacher, choir teacher, music teacher. Nice, nice. There you go. Well, it's glad to see another Luke. Welcome on in. Um, all good people. Yep. Did somebody ask about? Oh, Luke, how did things go on Saturday? So yes, Pezlos, things went great on Saturday. Um, I moved. I packed up and moved Epax, eSun, Cookie CAD, Bamboo. Um, didn't see any LDO. They might have this. I was moving all the stuff. I started off moving all the stuff in the back room, and I moved. And you've seen my pickup truck. I moved 2 truck beds full of of filament and and um the several printers, and they had printers that belong to the business, printers that belong to the workers of the business, and printers that they work on as part of the business because they do repair work. Um, and that's where they were doing repair work on a bunch of Creality stuff, and they used to sell Creality. That's one of the brands they started off selling was Creality and Comgrow. And they are no longer selling Creality printers because they now have deals with Bamboo and Prusa. They're a Prusa reseller. In fact, they just had to send some of their people up to Printed Solid in Delaware to be trained on repairing Prusas. So I know where I'm now buying my Core 1 through. But they sell bamboos and stuff. Um, yeah. So great group of people. They're tripling. They're a little more than tripling their floor space. So they're going to have like a whole back wall that's all printers, 2 whole walls that are all filament. They're going to have a polymaker zone. Um, they're going to have LVO, Prusa, and bamboo zones, and they'll have like 2 big, like 4 foot by 8 foot rolling tables that they can roll around in the main floor area and do like maker meetups and show people how to work on printers and stuff. So you may see some Digital Dragon 3D content coming to you live from Echovate 3D in Raleigh, North Carolina. Just saying. I'm going to try and go and chat with Beverly later this week or next week. So yeah. Also, happy Mardi Gras, Rove Tuesday, Fat Tuesday, Pancake Day to everybody. Well, Fat Tuesday, Pancake Day kind of, it kind of can coincide. One can lead to the other. One can lead to the other. So yeah, and I just saw merch. So we have water bottles, we have coffee mugs, because we all know that I love to drink coffee on stream. We do have shirts. I'm just wearing a KB3D one today because it's a little bit warmer than mine. I actually need to see if I can get these types of hoodies and do merch on them. Okay, so we figured out which material we're going to use. We're going to make a shim out of one of these. Not one of these. No. Crap, which one was I making shim? Big stock. It's going to be one of these. Not that one. There we go. That shim stock that'll go back in here. This is going to be the shim stock that we're... I'll double check. The shim stock's going to be the 0.1 millimeters. What I'm doing, flipping things. I will double check and make sure I'm using the 0.1 millimeter, because that is the one that we wanted to do. Get the tracking off of there, so that'll help. That will just give me the ability to do movements like this. What I can do is raise up my a tad bit, which it won't let me do. So good news is I can slide that out. We're going to use this piece. We're going to mark some of this stock, and I will probably not try and drill it out here because I only have one piece of wood up here, and I would want to drill into a piece of wood, and I'm not going to drill into a piece of wood that doubles as one of my shelves, because why? You don't want to tear up your benches. And this is safe. I have to do a home all. I'll let it home on that. I'll drop the bed down and swap them out. But I'm going to use this to get the whole pattern. And what I will most likely do is I'll just line up, cut it straight if I need to, because, which I don't think I'll need to. I'll just line this up on the edge, mark a straight line, mark the holes using my Sharpie, and we'll be able to do all of our cuts and stuff like that in one shot. So I make that mark, that mark, that mark, that mark. Knowing that the one in the center is going to be a 4. And quite honestly, what I really want to do is clamp this down onto like a 2x4 or something, drill out as many of the holes. So I'd probably clamp it like right here, do the 4 millimeter hole in the middle first, then switch out to the 2.5, do the 3 that I can do, move the clamp, do the last one. But you want to clamp it, because if you try and do this just straight holding it on something, like I said, you're going to tear this out. This is so thin. I can most likely cut this square edge off with my shears right here, and it won't even blink twice. And quite honestly, I do have clamps, and I can go into the table that's holding my laptop. You see how I'm talking myself into doing what I just said I'm not going to do, which is drill into my, it's not a shelf, it's a piece of plywood right over here that I use as a tabletop for the laptop and the keyboard. We'll move the keyboard. We will bring this over, get it lined up, clamp it down. I'm going to do it on the edge here. I'll get this lined up and clamped down again. Try and get as close as I can to the center bore hole there. The big thing is just making sure that once I start drilling, all of the holes are in the same spot. Now these are 2.5 millimeter holes. We could technically do like a 3 millimeter, and that way we know the shim's going to have space and we can kind of adjust things. Got the drill, and we've got some drill bits here. So let's just try and whack this out real fast. So 4 millimeter drill bit for the PTFE tube down the center. And by doing 3 millimeters for the rest of the holes, that will give us a little bit of play that we can rotate this around a little bit to get everything to line up. Because I do have a 2.5 millimeter drill bit in that, so I just see. Hey, Shadow Queen, how's it going? Just pulling up tabs at work. Hey, that works. We are trying to drill through some very thin shim stock to shim the right tool head of our IDEX, because it is ever so slightly different in height. Not there yet. And we are going through stainless steel. So through there. So we're through there. Now we need to drop down to at least a 2.5. You can do a 3, but if you have a 2.5, because the screws that we're going to be using here are 2.5 for the whatchamacallit. So and once again, we're just going to get lined up on the hole there and There's 2 holes, the center hole, now this hole. I think I just shot through the whole thing. Okay, so now we've got 3 holes and that center hole. Now what I might do is, do I have 2.5 screws? Those are all M2. Do I have some 2.5 screws? If I do, what I'm going to do is put some 2.5 screws in the holes and see if that'll help keep things aligned when I go to do the next part. Oof. 2.5 screws. So this should hopefully keep things aligned, especially since I went deep on a couple of these holes. And I'm just trying to keep the metal and the plastic bit here aligned. And if I need to, I will make that one just a tad bit deeper. Now that I've put holes in this piece of plywood. Take that off. And we'll shoot this next hole. And I think we're good. So got 3 of the screws in. So I think we're pretty good there. Now the hard part is deburring, which might just be one. Do I not? Coming back through the other side. Nope, that's not going to work. So I'll have to deburr this. Find the screw I just dropped. There we go. So we punch through one side, which means that side, chances are we don't need to deburr. So what I'm going to do is I'm going to hold this in place on here. Not use, need to use my, where's that? My deburring tool, which is basically an oversized drill bit. We're going to set this on that hole. Give it a quick turn. And that should get rid of any burr at the hole spot itself. Possibly even wallow the hole out a little bit larger, which is perfectly fine, as long as we don't catch and bend the material like we started to do there. All we're trying to do is take that little bump out, and that's what I was afraid of. This one started tearing. Might have to just use a light bit of sandpaper just to squish that, or not squish it, but to get the burr off. But yeah, that's it. That's what we're doing, is we're just sitting here trying to make a shim to get the tool heights of our IDEX closer to being aligned. And so the tool heights of the IDEX we're talking about is these two right here. This one's setting a little bit higher, and I would rather put a shim between the top plate and the top of the hot end heat break section itself of 0.1 millimeter, then try and rig something else up. Because anytime you start trying to play with torquing of screws and stuff like that, you can actually reduce the torque on your hot end, and next thing you know, you've got a hot end that is leaking. And well, that would be bad. And once again, I most likely can cut this material with this pair of scissors. And there's our little shim. Like I said, I'll have to try and hit it with some sandpaper real fast to knock the burrs off. I'm not trying to remove material because I need the thickness. I'm just trying to knock the burrs off. Especially any type of burr that would be on or around the PTFE tube, which would be the 4 millimeter hole in the center. This is where it might have been a little bit better to have printed 2 of those and sandwiched it between the 2. Might have helped with the blowout as well. And this is stainless steel. Okay. So that should be good to try and get as a shim on our material. One hole's a little bit buggered, but that'll be perfectly fine. The hole I'm really concerned about is the one in the middle, and if it's sharp in any way, it could dig into the PTFE tube and cause us some problems. So I did not get anything good from the Fabrico flash sale because I was not paying attention to Discord when it happened, and I missed it basically. Okay, so there we go. And this will be a more reliable over time shim. This is not going to change thickness like a 3D print might if you get some heat creep. I mean, it might expand. I doubt that it's going to expand that much to make a difference. I'm going to drop the bed down to give me some working room, and I'm going to turn the printer off because we're going to need to, one, get the motors turned off so that we can get in here and work on things. try and pry up the bed that there we go. Now what we're going to do is that's turned off. We'll turn this off. Move this to the front. And we need to take the orbiter off so that we can get to the screws to the hot end, that we can drop the hot end. I'll clip the zip ties on the hot end wires. I don't want to remove the hot end wires if I can help it, because the hot end, like the hot end wires are screw down terminals. So I prefer not to do that. And I'm going to change the camera angle and move this camera closer. I believe I can do that. Without killing myself, hopefully. How's that? Hey, works pretty good. Okay, so we need to take our orbiter apart. To get the orbiter off, there's two screws right here. To get to this one, you're going to have to take this off, and we also need to take the screw out here. So undo your tensioner. This will be a 2.0 driver. And I don't plan on undoing anything wire-wise here at all. I think I need to unclip the wire ties on the hot end and thermistor wires themselves, just to give me the room to move it around, basically. That comes out. We'll grab our 2.0 driver, or excuse me, 2.5 driver, and undo the two side screws. Those are M8 or M3 by 8 screws, and this should be able to lift straight up off the PTFE tube. Now that exposes the four wires, or shoot, the four screws that will have to pop off, and that will let us drop our hot end. And that's why we'll have to clip this one and this one to be able to get a little bit of room on maneuvering this. Be careful that you don't cut a wire when you're cutting your zip tie. That would be a bad day. Nope, nothing nicked. Ooh, I might have enough room right there, so I don't need to undo. Okay, these are going to be 1.5 millimeter, so thank you to LDO for getting me the 1.5 millimeter. These are tiny screws, so be careful that you don't flip these anywhere in the process of this. Now, if everything's good, I should be able to hopefully pull this down, out. All right, I am going to have to. There we go. That gives us enough room. We'll be able to get our shim in here. And what I want to do, hopefully use the PTFE tube to hold that shim in place against the top of our tool head. When we do that, we'll have the ability to turn this around some to line up the holes. Shiny material with holes. Great. That'll be the hard part, is getting the shim stock to be in the right spot when we get in here. If we get there's that. Ooh. Might have actually gotten real lucky and everything lined up. Everything lined up. How amazing is that? Come on. There we go. You can get one in there, the rest of them will line up pretty easy. Got some random stuff and lucked out. Got an ERKFA board for a 5160 driver. Do you mean the ERKFA Easy board, or which ERKFA board did you get? Hopefully this gets us into our Goldilocks zone, and if it doesn't, well, at least we know the process is pretty simple, and I'll just have to go and find the next size in the batch, and we can go and get that put in. So this will go on there. I think with it off, I'll have a little bit more room that I can put the zip tie back on here. Let me grab a couple of zip ties. Trying to work with a black zip tie on a black part on a black printer when you don't have any real light over here is fun. Okay, and I have not secured my wires down yet for my orbiters, meaning the sensor wires. They're supposed to come down and mount right to the end of the thing here, and I just have not gone through and done that yet. So we need to line the piece up on here and the back right here. So if we can get it kind of front to back, side to side where it should be, we should be able to line it up on the PTFE tube and drop it down just like that. Grab our 2.5 millimeter driver. Secure this in place. Just remember that you can't do any shimming above the plate. You have to do the shimming below the plate. So that's why we took the hot end off and shimmed between the hot end and the bottom of that metal plate that this is all sticking on. If you do it any other place, you're just raising this stuff up and not moving the tool head itself down. But once we get this screwed back in, we'll be able to run that same test again with the VAOC, get our nozzles lined up, and then see if our tool head distance got any better. Because the closer we have our nozzles to the same plane, the easier it's going to be to get our first layers down and get everything working together. For now, I'm going to leave this undone because once again, I might bring this wire down and add it to the group like they've asked. But I think this is good for now. I am going to have to move you all so that I can flip the switch over there to where the switch is at. So bear with me momentarily. I'll actually put you right here. There we go. Got it straight on. So we're up and operational again. Let's do a home all. I'm going to sit over here right behind you guys. Well, yeah, behind the camera and drink some coffee and watch things move. I know. I really hope this. I mean, theory-wise, this should work. So we do a home, we do a Z-tilt. And this is getting the build platform in line with the plane of the tool head, which should in theory be in line with the plane of the gantry. Okay, and our tolerance for doing the Z-tilt between those three probe points is 0.02, and the range that we got was 0.004907. So we are 5 thousandths difference between those 3 points. 5/1000ths of a millimeter difference between those 3 points. All right, now we're going to do the VAOC, and we're going to start our calibration, which is going to move everything to the back. And let me switch over to this display. So you can see what I'm doing here and see what it's doing in the smaller screen. So once again, this is heavily magnified, looking right into the nozzle, and the center of the bullseye there is sized for a 0.6 nozzle. So we're on a 0.5. That was toolhead 0, the left one. Now it's going to switch over to toolhead 1. And we're looking for consistency between the centers of these. So that's what we're doing, is we let it focus, and then we'll grab it and center the nozzle in the bullseye. Not going with the outer edge. I'm trying to center inside the inner diameter hole, not the outer diameter of the nozzle. And what I tend to do is come up here and go to like a 2x, which brings it even closer. So you can kind of fine tune it a little there. We're pretty close. I mean, I'm getting a little anal right here in the alignment. But that looks good. Switch back over to toolhead 1. Yep, that looks good. And if you want, there's the Z focus. This is actually moving the toolhead up or down. So you can move a little bit further away, like 0.1. See if that gets a little sharper image or not. So just, this is how you dial it in so that you're getting this nice sharp image, and you can get that ring view to center everything on the ring. So now that we have it left to right, front to back, pretty lined up and repeatable, now is where we'll do the calibrate the Z offset. Now, calibrate Z offset is done cold. And you'll notice right next to it, there's a calibrate thermal expansion. So you'll want to do that when you put in new nozzles, okay? You need to make sure that your nozzles are clean and you do not have filament loaded into the hot edge or the hot zone, because it's going to heat the nozzle up to 150 degrees and it could ooze, which will throw off. So what it's going to do is it's going to heat the nozzle up, let it heat soak a little bit, and then it's going to go over and do the same thing that it just did and bounce the nozzle on the end stop 5 or 6 times or more. And it does that process a couple of times at different temperatures to set the, to understand the thermal expansion and height wise of the nozzle and the whole tool head. So now that we're done, we can hit the X up here, or the box up here. That will close things out and set it. Come back to mainsail, and what I'm going to do is scroll down, and I'm going to see what my offset is here. And it says good toolhead Z offset of 0.038689 millimeter. Your toolhead Z offset is good, right? Looks like we're good. We have filament detected in both of our filament runout sensors. If you've been with the streams, you'll notice that I was having issues running prints. And I'll show you what I mean with some of the issues that I had when I was running prints. The other thing that I'm still trying to chase is, let me come up here. We've done a home. I'll do another home. I'll run a bed mesh. And I'll show you the other thing I'm chasing. Run a calibrate. Now, when it does the calibrate, it does it with the beacon. So it's going to scan the bed using the beacon probe. So you'll see it just go back and forth. So when it does home and Z-tilt adjust, by default, it'll use the nozzle to do a beacon contact. And now it's scanning with the eddy current sensor, basically. And here's our mesh. It's a 0.26 millimeter. And you'll see that it's falling off. The thing to remember is look at your X and Y. By default, you look at this and you may think, oh, this is my X, it's the front right corner. No, this is your X, and this dropped corner is the back right corner. So in order to fix that, what I need to do is take the side panel back off. I can loosen the corner screws that the mount, so the motor mounts are mounting onto this and this rail. So I loosen the screw that's holding this rail and this rail on the corners, and I'm going to tap the underside of this motor a couple of times, maybe with the dead blow, to bring it up a little bit, and then I'll tighten it back down. That's how you get the frame fully de-skewed, right? So that's something to be aware of. It's not bad. It should be able to compensate. We've all seen beds like this. That's not a huge deal. And the 0.206 deviation, the high spots, that's 0.1. Over here, it's 0.04, 0.05. And then it's just low over here by 0.1. But it's in that back corner. Shouldn't give us a problem. Now, you saw that when I come up here full display, you saw me print this and it was in single mode. By default, your printer comes up in IDEX single mode, okay? I have the option of doing an IDEX copy or an IDEX mirror. So if I have a figure standing here facing this way, say the jackbot, and he's standing like this, when I do a copy, the one on the right is going to be facing that way. If he's standing like this and I do a mirror, this side is going to be the mirror opposite. So if you're needing to print a part and it has to be mirrored so that they join together, you can actually print them at the same time, load up the same material and print them at the same time, as long as it fits on one half of your bed. Right? That's kind of neat. You can do two parts at a time. So what I want to do is, rather than IDEX single, I'm going to click on IDEX copy. you'll see the two nozzles come out and join together. And what I'm going to do is I'm going to try and print that mount piece again. And you'll see I didn't change any G code. That is the coolest thing here. It's the same sliced G code. Everything's being done by post-processing scripts. And it says, I'm mirroring it, okay. I'm going to move them both over and center them on the bed that's available to that tool head. And it's going to print both of them same time. If I'm doing the mirror mode, then it'll do whatever it needs to do to flip the movements 180 degrees for toolhead 1. That's the coolest thing. You don't have to. So your slicer, there's nothing in the slicer for I'm going to print in a, two at the same time, or I'm going to print a mirror mode. It's just setting up and printing a piece. So setting something like this, it comes right in the middle and it will move it over when I go to do the IDEX print. Now, something you won't want to do is, let's say we'll scale this to, what's the largest? Let me say, move that to 125. Really? That's not what I wanted. I wanted the X dimension to go to 125. And I am not in uniform scale mode. Uniform scale mode, X. Let's go 150, right? So this is supersized. I can print this with a single head, right? I can't print this, maybe. Doubt it, but I could potentially print this in copy mode because the tool heads are moving left to right together, right? So when it's printing this edge over here, the other tool head is printing this edge over here. So there may not be a collision with the other part and the tool head. If I'm doing mirror mode, I will get there's an exclusion zone right down the middle because the two are coming together in the middle when doing the mirror. And you've got to account for the width of your tool head. So when you go to, it'll let you slice it. When you go to print in a mirror mode, it should error out and bark at you. And what I'm going to do now is go back to just the bench side so that we can look at this. So you saw it poop, you didn't see it poop here. It just, the filament wasn't down far enough. And of course, it's going to be harder to see this side because it's a dark filament and lighting sucks. So let me see if I can add some lighting that will at least glint off that a little bit. Now, you'll see that this is a steady light and this light is blinking. This is tangle detection tripping. I had to shut off tangle detection or this would constantly cause a pause. The filament's not tangled. It is the very long PTFE tube path that is tripping the spring in here and causing tangle detection to trigger. So the only way I could get it to work is to bypass tangle protection. Okay. Yeah, I'm over extruding. I need to fix the extrusion multiplier here. But I will say that this is the farthest I've gotten on a copy print yet to date. So you are seeing a first time copy print right now. Successful copy print to this stage. And once again, when I say a very long PTFE tube, it comes down here right in front of the spool, all the way up, down, around, and over to the tool head. So it's a good meterish long. And I have swapped both of these over to 3mm inside diameter reverse Bowden tube. And that just popped off. Dang it. So we'll cancel this. And so that first layer, I mean, yes, I can see the layer lines. It could probably use a tad bit more squish. But I don't think yeah, I mean, I thought it was over extruding, but that's not over extruding either. So I think really the issue is just possibly needing to drop it down ever so slightly on the the Z offset on this. Maybe harder to see, but we've got a little bit of gapping on this one. I think our Z offset, and once again, I think speed wise, we're overrunning our filaments. So let me do two. What do I want to do? Best way to do it would be to reslice the file rather than knock down the speed some other way. So what I'm going to do is come in here real fast. And like I said, it's cooking, right? It's moving pretty fast, 350 for inner walls, 250 for small perimeters, 400 for infill. It's just moving. So all I'm going to do is come in here and just drop things by like 100. Like I said, from the one print that succeeded, we're obviously going a little bit, we're ringing and stuff. So top surface, I'll leave it 100. Got fill support, that's good. Accelerations, max here is 10,000, that's fine. The default Prusa slicer, I think, is set to like 50,000. And this thing shakes like mad if I'm going that fast. Yeah, it was going good until that release. So I think part of, like I said, I need to slow it down because I think I'm overrunning the material a bit. And then when we go to actually print, I'm also going to drop it like 0.05. See if we can get just a tiny bit more squish. So G-code files, this is the one we just did. Oops, cancel that. Come in here. I want to make sure that we are in IDEX copy mode. And I think it just told me printer's not home. Home. And technically it wants you to do a manual VAOC before you do copy and mirror mode or a two tool head print of any kind. I don't think it's going to be super critical on a copy or a mirror, as long as you know that mechanically they're within the range like we are right now. So I put it in copy mode again, and we're just going to rerun that file in copy mode. And I'm going to want to adjust the height ever so slightly, right? I'm going to drop the overall Z height once it gets ready to start printing down just a smidge and see if that will help us out. And like I said, I think primarily it just boils down to going too fast, and I really need to take some time to tune this printer in, and tune the various materials in as well. Like right now, I'm printing PLA. When I go to do ABS here in a little bit, I'm gonna have to probably tune that unless, well, so here's the thing. I'm also using Orca Slicer on this machine, which isn't the quote unquote approved. The approved version is Prusa Slicer, Orca Slicer. The only way I'm able to run it right now is running Orca Slicer 2.3.0 beta. It's close, and there's nothing that stops me from basically pulling up the Prusa Slicer and basically putting one up on one monitor, one up on the other monitor, and doing a big copy paste back and forth. Now I'm just going to go ahead and drop it. I think I'm going to drop it 0.075. As it didn't take either one that I clicked on. Maybe it did. And I did wipe this off yesterday. And I don't know if you can tell. Oops, let me go back to here. And I'm going to pull you all back just a little bit here and see if you can tell how much this thing is rocking. Yes, a little bit hard to tell there, but it is rocking. There's the RatPack right there. It definitely will shake, rattle, and roll. It's doing the dance. That's true. Now remember, like I said, when we do this in mirror mode, it basically goes, the X is going against each other, which does help in the vibration dampening some. It does cancel each other out a bit. Maybe what we'll do is we'll run this in mirror mode after this. But these are just small, quick prints that if they're going to fail fast, as we saw earlier. And we've broken free again. Cancel that print. All right, we broke free again. Our first layer is definitely getting squished more. And you know what? Looking at that, I'm starting to see some bowing. I'm wondering if we've got too much cooling on it. We might actually be blowing too hard on it. Well, the left side is definitely down. Left side is definitely down a little bit further than the right. So we still have a little bit of a discrepancy in the heights. It's not much, but the other way that we can get around that. Oh, we already have it. I was going to say is making the first layer height a 0.3 instead of a 0.2, which I already have here. Huh. I'm going to save the config and try and save that offset so I don't have to chase it as fast. And let's try the cube. Not the RatRig cube, but the calibration cube, the Orca cube. Make sure we do the one that was done in PLA and not the one that was done in ABS, because reasons. Like we have PLA installed. This will give us a little more, I'll say, meat to the base of the print as well. And once again, with the speeds, I think I slowed this one down a bit on the start. This should hopefully help out. Like I said, I did wipe the bed off. I mean, worst case scenario is I could put a little bit of vision miter on. You know, put a little bit of vision miter on. Yeah, vision miter would definitely fix it all. No bed issues after doing vision miter. Oh, dang it. It's running single mode. Got to put it in copy mode. Dang it. That was a little warm. Home. There we go, in copy mode. Print. What is going on with that now? Like failing for some reason. It's throwing an error for some reason. Don't know why. Rethink yourself. Okay, let's try that again. Home all. You know what? I don't think I pig calibrated the P1. Right, I'm confused now. This is throwing an error. Throwing an error when it's doing the post processing. This object has no element. Not sure what that is. Try this one. That work, or do I need to flop it around again? Maybe I just need to have a rethink everything. Okay, are we back up and running yet? Are we back up and running yet? Come on. Okay. Redid all of our thinking. I'm going to completely reslice this. I'm going to delete that because this will have all of our speed reductions that we put. Calibration. Add handy models. We'll do an Orca cube. Okay. Slice plate. Upload. Okay. Should have a newly sliced Orca cube. Going to home and tilt. Going to an IDEX copy. I don't know. It may be complained because we didn't do the VAOC thing either. So maybe let's try and go through that whole process like we're supposed to, and see if we get ourselves out of the jam, out of the jammy jam. Okay, so we did a home. We're going to do a Z-tilt. Sounds like it's done. Now we're going to go into the VAOC, start calibration. Bear with me 1 second here. I'm trying to get another print started. I am working on printing parts for a death racer. Oh, and for those interested, I should have parts in tomorrow. Well, actually, by Thursday. I'm not going to say I'll have them in tomorrow because, well, post office keeps complaining about, weather and fires and, all that. So here's the thing. In this view, you see that the nozzle itself is clear. And let me try. Okay. You see over here on the right, this is some filament that's up around the edge. As long as it does not appear to be underneath the nozzle, you're good. Same thing with toolhead 1. You'll see that there's some in the nozzle, but it's internal up in the nozzle. It's not below the nozzle. And then you get a bunch of it around the nozzle there. You're fine there as far as doing your Z offset calibration. It's just basically saying make sure that you don't have any filament on the nozzle. And if you want, even though I'm not heated up, what I can do, reach around here under the bed, do a little brushy brush. Over here, do the same thing. Little brushy brush. We're cold, but it should make sure that there's nothing right there at the nozzle. We're lined up pretty good here. I'm going to calibrate Z offset. Just going to check the Z height offset here. Okay, stop that. Back into mainsail. We can check that our toolhead Z offset is still good. 039. Okay. Are we homed? No. So we'll home again. And we're going to scroll down here and we're going to put this into IDEX copy mode. Come up here and grab the file that we just uploaded with the new Orca cube. See if it yells and screams at us again. No yelling and screaming. So I guess we need to do the Z height to solve its complaining. Toolhead 0 temp was reached. It's going to do its beacon calibration. What it does is it scans across the front with the scanner, then it does the touch in the middle, and this is how it defines the difference between the height that it scans and the height that it touches, so that when it does its scan, it knows where the Z offset is, quote unquote true Z0. Goes back and sits on its pads while it heats both tool heads up. Okay, so it's doing its little blob deposit. Still looks like it's off. I may wind up going up one more shim level. I'll have to see what I have. I'll do that off stream. Didn't think to slow down the fans any, so if it's still crazy on the fans, we'll see. And it is peeled up on the left side now. All right, so yeah, I think we're now into, I'm going to go and do a deep clean on this bed later tonight and vision miner it. And I will make another attempt later tonight with a little bit better bed love, is what I'll say. So with that, that's kind of where we're at. We're now close with the nozzle. I'll look at the shim material and see if I have a shim material that's like, if I've got a 0.15, I will use that. If I don't, then I'll have to think, because I don't want to double stack shim material, because then I'm using like that was in essence tinfoil, and it's, you know, trying to double stack that with one that's that loose will be a pain. I'd much rather get one that's a little bit thicker, even if it's too thick, and be where the right side is slightly higher than the left. And by slightly, I'm talking, you know, hundredths or thousandths of a millimeter. But yeah, that's where we are. I know I can get a cube printed with a single head. It's trying to get it done in a dual head configuration, and I do think that part of my issue right now is the speed. I need to slow it down. I need to work on belt tensioning and input shaper some more to get this printer really tuned in. By the way, I'm not sure if you can see, but there's some things sitting back here. Like I said, I'm starting the prints for a Death Racer build. I'm not sure if you guys want to see that. I think a lot of people have built Death Racers, so I don't know if there's much new about that can be shown. Saturday, though, we will deviate and go into a different style project for the stream. And I don't think there's going to be any 3D printing involved in it, but it's going to be doing the tear down, deep cleaning, and possibly some rewiring and stuff like that of a 1949, early 1950 Singer model 1591 sewing machine. So the 1591 is the one that had the potted motor. The other versions of the 15 model series would have been either hand or treadle, which would be like a big paddle at the bottom of the thing that you just basically foot powered. And this machine, looking at it and everything, it's like you could do heavy canvas and leather sewing with this machine. Like this was a no slouch, like old school, robust cast sewing machine. Not the plastic stuff that we have today that you can go, oh, I want these 3 different things done in this pattern, and you basically program it and it spits out a sewn part for you. This was old school, and it's going to be a neat little thing to learn to go through and do some cleaning and stuff like that. So that'll be a project that we'll do, and I'll do the teardown on the stream, and then we'll see. We'll have some other content in there. Maybe this will be the Saturday project, but it's going to be a lot of some tedious stuff where we're working on using some chemicals to deep clean some of the metal parts. If it's bare metal, I can use solvents. I cannot use a solvent on the black lacquer finish. I will take off the lacquer finish. It's a couple of coats of black lacquer. It has some decals on it, and then it would be clear lacquer. There's parts where you can see that the decals have been worn off. That also means the clear lacquer coat has been worn off. and we're just down to straight black lacquer. So I got to be careful and use things that will not damage that paint, because I do not want to have to do a full type restoration to this. I want to show, I mean, it was used. This was Mrs. Dragon's grandmother's sewing machine. So, but that's kind of where we're at tonight. I need to play and tinker with this, and I don't really want to do that type of tuning on the stream. I did see that there's various other people going on right now. It looks like Lee Marie is up and running, doing something with the RatRig as well. I don't know what that is. I don't know if they've gotten a RatRig that they're upgrading or playing with. Don't know. But let's go find somebody that we can raid into. Blowing the sawdust off of the laptop from where I had blown it on there when I was drilling holes in my desk. MakerDex, Cyber Jewels, Polymaker. Hey, Polymaker's up and running. Joe Mark Makes is getting ready to start soon. You guys want to go over to Polymaker? I know it's kind of early. Looks like they're looking at, you know, community talk, event planning. It might be getting ready to give the giveaway or do the giveaway. So I'm gonna go ahead and get a raid started to head over there. I need to grab some food as well. I haven't eaten that much today. And like I said, this is just going to be some tinkering. This is the first ever IDEX that I've ever owned. I know I can print with a single tool head, but I do need to try and figure out the IDEX. And I think the best thing to do is just slow everything way down, get it working, and then slowly start working it back up. Thank you for the follow, Shocker2122. I appreciate that. And yeah. Thank you, everybody, for being here. Let's jump over to Polymaker. I'm going to try and get you over there real quick before they do the giveaway. So as soon as you get in there, if you're not already there, type "I am awesome" in the chat to get entered in that giveaway. And thanks, everybody, for being here. And we'll see you all on Thursday. Bye now. If you are watching this content a little bit later on YouTube, be sure to like and subscribe if you like the content and you want to see more. And make sure you click on that bell to get notified of new content when it comes available. And YouTube's going to offer up a suggested video right over here. Thanks now.